Okay, so welcome back. And now what we're going to do is we're going to talk about solving linear equations that contain fractions and decimals. So let's start with fractions to begin with. So when we have fractions, like I said in an earlier video, one of the things that we can do, one of the techniques that is often used that helps simplify things is to get rid of the fractions by dividing by the denominator in the denominator of the fraction. So we basically just use the addition rule, no, not the addition rule, I'm sorry, the multiplication rule, in that case by multiplying everything by the reciprocal, okay? Or in the way we're going to describe it is to multiply everything by the number that's in the denominator, okay? To get rid of all of the denominators and so that we're just dealing with an equation that contains integers, okay? So that's what we're going to be doing. Now, so all we're using is the multiplication principle to simplify things, okay? So, let's look at some of these. So the first one, we have 4d over 3 is equal to 12, okay? And so what we're going to do is we're just going to multiply everything by 3. Okay, to get rid of the fractions. So let's do that. So if I multiply everything by 3, right? I'm going to multiply this by 3 and this by 3. Well, 3 divided by 3 gives me 1. So then I just get 4d equals 36. And now I just divide both sides by 4. So here I get d equals 36 divided by 4, which gives us 9. So d equals 9 is the solution, okay? Is the root. Okay, so now what about b here? Let's do b. So here's what I'm going to do first. I'm going to divide, so there's a denominator of 4 here. So I'm going to multiply everything by 4. Multiply both sides of the equation by 4. Okay? So I'm going to multiply 2x by 4. I'm going to multiply 3/4 by 4. And I'm going to multiply 1 by 4. And so I get 8x here, plus, well, 4 divided by 4 gives me 1, so I end up with 3. And then 4 times 1 is 4. And now I've got the equation. Now it has no fractions, and now I can solve. So now all I'm going to do is subtract 3 from both sides. So this gives me 0, and I get 8x equals 1. And then of course if I divide both sides by 8, I get x equals 1/8. And again, you could check your answer, and I recommend that you check your answer. Go back and plug 9 in for d here, see if you get the same answer on both sides. And then plug 1/8 in for x here and see if you get the same thing on both sides. And you will. Okay? So now, there's other situations that come up that really make this nice, is that you will sometimes get x in the denominator. And so you can apply this principle even if x happens to be the denominator. Okay? Now also, if x is in the denominator, you got to be careful, because remember, one of the things we can't have in the denominator is 0. Remember, the addition rule, or excuse me, the multiplication principle works when? Remember the principle. It works when what? The quantity that you're multiplying by or dividing by is non-zero. Oh, sorry. Okay, non-zero. So if x is in the denominator, like in these cases, we have to assume that x is not 0. Which means there's this idea of what values are okay in an equation. So these are what we call excluded values, okay? So values that will not give us a true statement. So what are values that will not give us a true statement? There's actually a term that you want to know for this. So again, we call roots, right? The roots of an equation are all of the values of the variable that will give us a true statement, right? So what do we call those values that do not give us a true statement? Those are what we call the extraneous values, okay? So extraneous values are values of the variable that will not give us a true statement, okay? They give us a false statement. So we also call those values excluded values, okay? We do not want to include those in our solution set, okay? So excluded values are values that maybe we solve for, but they have to be excluded because they, for example, cause 0 to be in the denominator, okay? So let's do some examples and you'll see what I mean. So let's do this one first. So here we have this example. We've got 10 divided by x over 2, or equals to 2. So again, what we're going to do is we're going to use the multiplication principle and we're going to just multiply both sides by x. No problem. Let's do that. Again, we're assuming x cannot be equal to 0, right? So x is not equal to 0. Okay, so 0 is an excluded value or an extraneous value. Okay, so we're going to multiply this side by x. We're going to multiply this side by x. And so what does that give us? Well, x divided by x, right, as long as it's non-zero, is 1. So we get 10 equals 2x. And now what we're going to do is we're going to divide both sides by 2. Right? We're going to isolate the x variable. And what do we get? We get 5 equals what? X. Or x equals 5. And that's it. So we're good. So the root is 5. Okay, now let's do this one here. Here we got 0 over x equals 5. Now immediately some of you might be looking at this as, well, that can't work, right? Is there a number that I can divide by? Is there a number that I can divide 0 by that will give me 5? No, of course not. But let's work this out. So first of all, x is in the denominator, so we know we cannot have x in the denominator, right? Okay, so now, but let's multiply both sides by x. So again, I'm going to multiply this side by x, multiply this side by x, and I get what? X divided by x is 0, as long as it's non-zero. So I get 0 equals 5x. Well, now if I divide both sides by 5, what do I get? I get x equals 0. Ah, that can't work, right? We already said that x can't be 0 because we can't have 0 in the denominator, right? So, but then our solution says that x is 0. Well, that tells us that there's no solution to this equation. Okay? Okay. That's it. Have a great day.